Okay, we're going to start our next unit on radicals with section 3.1, just simplifying radicals. So this example up at the top wants us to simplify square root 375. So one thing I want to point out that we're not going to do is just type in the calculator square root 375 and put that decimal answer. None of our answers will contain any decimals. So we would just want to simplify it without changing it to a decimal. So the steps to do that are listed up at the top. The first thing we're going to do is find the prime factorization of 375. Now the prime factorization, if you'll remember, breaking down numbers into products, so numbers that multiply together to give us 375, and we want these numbers to be prime numbers. So our prime numbers, 2, 3 is a prime number, 5 is a prime number, 7 is a prime number. 9 is not a prime number because 3 and 3 go into 9. Remember, a prime number just has as its factors itself and the number 1. So that's what a prime number is. So we're going to break this down into prime numbers that multiply to give us 375. So the first thing you can do is take 375 and divide it by a prime number. So 2 doesn't go into it because it's not even. 3, let's add 3 and 7 together to get 10, plus 5 is 15. And 3 goes into 15, so 3 will go into that. But I think the easiest prime number to see that goes into 375 is 5, and it is prime. So 375 divided by 5 is 75. So you'll want your calculator to help you with this division. Now since 5 is prime, we're going to leave it alone. 75, let's break down. 5 goes into 75. So let's divide 75 by 5, which is 15. From here, we can leave this 5 alone, break 15 down into 3 times 5. And 3 is prime, and so is 5. So now that we've broken down into this factor tree, we're going to list all of these prime numbers underneath the radical. The order that you list these doesn't matter. So I have 1, 3, and then I have 3 5s here. So I'm listing these prime factors underneath the radical sign. Now, one thing that might be helpful for you to know is check to make sure this does equal 375. So let's type in our calculator. 3 times 5 times 5 times 5 equals 375. So we factored it correctly. Okay, step 2 is to look for pairs. And pairs mean we need a pair of these numbers in order to break out from underneath this radical symbol. So once we find a pair, I'm just going to circle that pair. This pair is going to come out front. When it comes out from underneath the radical sign, it just comes out as 1, 5. So any numbers that are left behind, which would be 3 and 5, they have to stay underneath the radical sign, and we'll multiply those back together. So bring out this pair of 5s as 1, 5. Put the radical symbol. And then our loners that are left behind, 3 and 5, we're going to multiply together to get 15. So our simplified answer is 5 square root 15. Okay, now that we have the general idea, let's go down and do the first practice problem. So the first thing we're going to do is break 75 down so that we've factored it into prime factors. So 5 goes into 75 15 times. Break 15 down into 3 times 5. Go ahead and list our prime factorization underneath the radical symbol. The order that you write these doesn't matter. Just make sure that you get each one of the prime factors. So after we do that, we circle the pairs, because the pairs can break out from underneath the radical symbol as 1, 1, 5, not 2. And then the loners left behind, there's just one loner this time, that's square root 3. So the 3 has to stay beneath the square root symbol. So 5 square root 3 is our simplified answer. Okay, let's take 112. 2 goes into 112 because it's even. 2 goes into 112 56 times. 56 is also divisible by 2. And it doesn't matter what you first divide into this 112. Someone could take 2 into it, someone could have taken 4 into it and then broke the 4 down. You can take any two numbers that multiply to give you 112 and go from there on your factor tree. So 56 divided by 2 is 28. Well, 28's even, so I'm going to divide it by 2. 14 is even, so I'm going to divide it by 2. So I'm breaking this down until I get down to a prime number here. So I have 1, 2, 3, 4 2's that we're listing, and 1 7. Again, you can double check that. 2 times 2 times 2 times 2 times 7 will give us 112. Okay, now we're looking for prime, or we're looking for pairs. They already are prime. And this time we have 2 pairs of 2's. So we're going to bring this pair of 2 out and this pair of 2 out and multiply those together to get 4. The 7 stays underneath the radical. He's the loner, so he stays underneath the radical. So 4 square root 7. Okay, let's break 252 down. Since it's even, I'm going to divide it by 2 to get 126, and then I'm going to divide that by 2 to get 63. 63 is not divisible by 2, but we need another number that goes into 63. Well, 3 is prime, and it goes into 63. 3 times 21. 21 is divisible by 3 and 7, and both of those numbers are prime. So make sure when you're listing these prime factors, we get every one of them. So I'm counting 2 2's, 2 3's, and 1 7. Okay, now let's go ahead and find our pairs. So we have a pair of 2's that will come out front, multiplied to a 3 that comes out front. Remember, when it comes out front, it's just one of them. And the 7 is left behind. So 2 times 3 is 6, and then square root 7. Okay, let's go down to square root of 54. Well, I know 9 times 6 is 54. We can break 9 down into prime numbers, 3 times 3, and we can break 6 down into prime numbers that are multiplied, 2 times 3. So now let's list our prime numbers underneath the square root sign. We have 1, 2, and we have 3 3's. Okay, so coming out from underneath the radical, let's find our pairs of numbers. So we have a pair of 3's that will come out front as 1 3. Underneath the radical, we have 2 and 3 that we need to multiply together. So our simplified answer is 3 square root 6. Okay, this next one's a little different because we have a number out front. We just need to make sure when we break down into prime numbers that we leave this 2 out front, and it's going to multiply to anything that we bring out front. So 243 is not even, so let's see if 3 goes into that, which it does. 81 time. Well, I know 9 times 9 is 81, and then I can break 9 down into 3 times 3. So I am counting 1, 2, 3, 4, 5 3's underneath this radical. So from here, let's circle our pairs of 3's. So this pair of 3 comes out, this pair of 3 comes out. So we have 2 times 3 times 3. Underneath the radical is just the 3. Don't forget that 2 that was in the beginning. So 2 times 3 is 6, times 3 is 18. And the loner is the 3 that stays behind. Okay, number 6, break 27 down. I know 9 times 3 is 27. 3 is already prime, but 9 breaks down into 3 times 3. Don't forget to put this 3 that's out front in the original problem. So we have a 3 out front, and then we have 3 3's underneath the radical. We're going to bring out one of these pairs of 3's and multiply it to the 3 out front to get 9, and then the loner 3 stays underneath the radical. So these actually get kind of fun as you work through them. Let's break down 200. 200 breaks down into 2 times 100. 100 breaks down into 10 times 10. 10 breaks down into 2 times 5. So let's count up the number of 2's that we have underneath here. 1, 2, 3. And 2 5's. And don't forget the 4 out front. So let's circle our pairs. We're circling a pair of 2's that comes out as 1 2, a pair of 5's that come out as 1 5, and the loner is a 2 that stays underneath the square root. So 4 times 2 is 8, times 5 is 40, square root 2. All right, go over to number 8. Let's break down 80. A lot of things 80 will break down into. I'm going to do 4 times 20. And then I'll break 4 down into 2 times 2. I'll break 20 down into 5 times 4. And then I'll break 4 down into 2 times 2. So I'm counting 1, 2, 3, 4 2's. And don't forget that 5. So we have 4 2's and 1 5. So finding our pairs of numbers, we have 2 pairs of 2's. Don't forget the 5 out front, so 5 times 2 times 2. And then there's a loner of 5 left behind. 5 times 2 is 10, times 2 is 20. Square root 5 for our simplified answer. All right, 486. Let's divide that by 2. Get 243. That looks familiar. Up on number 5 we had 243. We already broke that down. We know it breaks down into 1, 2, 3, 4, 5 3's. So we're going to use that problem. And let's see, we have a 5 out front. We have this 2. And then we have the 5 3's from 243. Okay, from here let's circle our pairs of numbers. So a pair of 3's go out front and a pair of 3's go out front. So we have 5 times 3 times 3 out front. Underneath the radical we're left with 2 and 3 that we're going to multiply together. 5 times 3 is 15, times 3 would be 45 out front. And then underneath that radical is 6.